Hello and good evening to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss the next fit, the best fit, and the worst fit memory allocation schemes. To begin with, let us try and understand the next fit memory allocation scheme. As we have all learned, in case of first fit memory allocation scheme, the tendency is to have the allocation clustered towards the lower order address space. As a consequence, there will be large number of fragments being created in the lower order address space, whereas there are blocks of larger size located in the higher order address space. So, in order to prevent or avoid creation of such kind of scenario, we need to have a memory allocation scheme that uniformly allocates memory to the requesting processors, which means we need to have a memory allocation scheme that is capable of allocating memory judiciously across the memory space. Now this is one of the prime objective of next fit memory allocation scheme. So next fit memory allocation scheme tries or attempts to allocate memory to the processors more evenly across the memory space. Because of the effectiveness of the next fit memory allocation scheme, it is a memory allocation scheme that is often preferred. Now in case of next fit memory allocation scheme, in order to have more even distribution of processes over the memory, we start the search for the hole from the last allocation. So in case of next fit memory allocation scheme, the searching process to determine a hole that is capable of accommodating the process starts from the last allocation. In case of first fit, search starts from the beginning of the memory address space. So in case of next fit memory allocation scheme, to have a more uniform distribution of processes over the memory space, we will start the search from the last allocation. In order to facilitate the ease of memory allocation, the list is considered to be a circular one. That means we will start from the last allocation and we will go in a circular manner and search for a block that is large enough to accommodate the process. In situation, if you do not determine, or if you are not able to determine a block that is large enough to accommodate the process during the circular movement, then we deem the search process to be a failure. So which means that search process is considered to have failed if we come back to the place where we start without finding a suitable block. So since we consider the list to be a circular list, so if we reach the point where we had started from without finding a suitable block to accommodate the process, then we say that the next fit allocation scheme has failed to allocate memory to a requesting process. Now let us try to understand next fit memory allocation with the help of a suitable example. Now here let us consider AN represents an allocation request and DN represents a deallocation request of n kilobytes respectively, and we are assuming the size of the memory to be of 100 kilobytes. So then let us consider the allocation sequence and let us try to attempt allocation using the best fit memory allocation scheme. The next fit memory allocation scheme. So here we have an initial request of 20 kilobytes. So 20 kilobytes of memory is allocated. So we have 80 kilobytes of free address space. After that, there is an allocation request of 15 kilobytes. So 15 kilobytes of memory is allocated to the requesting process. So we have a free memory space of 65 kilobytes. Then we have a request of 10 kilobytes. So now the depletion of the free space goes to 55 kilobytes. Then we have a request for 25 kilobytes. So now we have the free space depleted to 30 kilobytes. Then we have a deallocation request of 20 kilobytes. So once the initially allocated 20 kilobyte is deallocated, so we have two holes of size 20 and 30 that can be utilized in order to accommodate processes requesting for memory. Then we have a deallocation request of 10 kilobytes. So once 10 kilobytes of memory is deallocated, so now we have three holes of 20, 10 and 30 kilobytes that can be used in order to accommodate process requesting for memory. Now we have an allocation request of 15 kilobytes. So as said, in case of NextFit memory allocation scheme, allocation starts from the last allocation, right? So the last allocation was of 25 kilobytes. So now the allocation will start after the last allocation that was of 25 kilobytes. So 15 kilobytes will be allocated after 25 kilobytes. So this is the way how NextFit memory allocation scheme attempts to have a more even distribution of allocation over the memory address space. Then we have an allocation request of 10 kilobytes. So further memory allocation will be done after the last allocation that was of 15 kilobytes. Then we have a deallocation request of 25 kilobytes. So now we have three holes of 20, 35 and 5 kilobyte that can be utilized in order to accommodate process. Now we have allocation request of 20. So since we had said that in case of NextFit memory allocation scheme, we consider the list to be a circular list and we will move in a circular manner in order to determine the block that can accommodate the process. So on moving in a circular manner, the block that can be allocated to a process that is requesting 20 kilobytes of memory space is the initial 20 kilobyte that was previously formed after the allocation by a given process. So the initial 20 bytes will now be allocated to the process utilizing the properties of the NextFit memory allocation scheme. So this is the way how NextFit memory allocation scheme works. Now let us discuss the BestFit memory allocation scheme. BestFit memory allocation scheme allocates the free block that is closest in size to the request. So the block that is closest in size to the request is allocated to the process requesting for the allocation of memory space. Now here the list is searched for a block that is smallest but greater than or equals to the requested size. So here what do? We search for a block that is the smallest but it's capable of accommodating the process but greater than or equals to the requested size. Now, like the first fit algorithm, best fit tends to create significant external fragmentation but keeps larger block available for the potential larger allocation requests. So here the advantage is that in case of best fit memory allocation scheme, so since we look for an optimal size that can accommodate the process, the larger blocks can be left for allocation to the process that requires larger bytes of memory. So this is the way how the best fit algorithm performs its operation. So in order to understand best fit algorithm, let us consider a situation. So let AN represent the request allocation of n kilobytes. Likewise, let Dn represent the deallocation request of n kilobyte, and let us assume that the total size is 100 kilobytes, and considering the allocation and deallocation request, we need to perform memory allocation using the best fit allocation scheme. So here green represents allocation and red represents free space. So initially we have an allocation request of 20 kilobytes. So after allocating 20 kilobytes, we have 80 kilobytes of free space. Then we have allocation request of 15 kilobytes. So after satisfying allocation request of 15 kilobytes, we'll have a free space of 65 kilobytes. Then we have allocation request of 10 kilobytes. So after satisfying the allocation request of 10 kilobytes, we have free space of 55 kilobytes. Then after that we have allocation request of 25 kilobytes. So after allocating 25 kilobytes of address space, we have 30 kilobytes of free space left. Then we have a deallocation request of 20 kilobytes. So the initially allocated 20 kilobyte is now deallocated and can be used in order to allocate memory to the process that is requesting for it. So currently we have two holes of size 20 and 30 kilobytes that can be utilized. Then we have a deallocation request of 10 kilobytes. So on deallocating 10 kilobytes, we have three holes of 20, 10 and 30 kilobytes that can be utilized in order to accommodate process that is requesting for execution. Then we have an allocation request of 15 kilobytes. Now in case of BestFit, what we try to do is we try to look for a block that is large enough to accommodate the process but is smallest among all the blocks that can accommodate the process. So here there are two blocks that is large enough to accommodate the process, but that is 20 and 30, but 20 is the block that is smallest among all the blocks that can accommodate the process. So the 20 bytes will now be allocated to the process requiring 15 bytes. So 15 bytes of memory is allocated and we have a free space of 5 kilobyte. So now what we have is we have three holes of 5, 10 and 30 kilobytes. Then we have an allocation request of 10 kilobytes. So the 10 kilobytes can be best fit in a free space of 10 kilobytes. So here we have allocated 10 kilobytes to 10 kilobytes of free space. Then we have a deallocation request of 25 kilobytes. So we have 25 kilobytes of memory deallocated. So now we have free space. One is of size 5 kilobyte, the other one is of size 55 kilobyte. Then we have an allocation request of 20 kilobytes. So now from the 55 kilobytes we will be allocating 20 kilobytes to the requesting process and we are left with 35 kilobytes of memory space. So this is the way how the BestFit algorithm attempts to allocate memory to the requesting process. Now let us discuss the WorstFit memory allocation scheme. As the name says, WorstFit memory allocation scheme attempts to allocate the largest block for every request. So in case of WorstFit memory allocation scheme, the largest block will be allocated to the requesting process. So in WorstFit allocation scheme, the largest block will be allocated to the requesting process. Here the list is search for a block that is the largest among all the blocks, that free blocks that are there available in the memory, and the largest of the blocks will be allocated to the requesting process. So it does have one advantage. So if most of the requests are of similar size, a WorstFit policy tends to minimize external fragmentation. So this is one of the advantage of WorstFit memory allocation scheme. So if most of the requests are of similar size, a WorstFit policy tends to minimize external fragmentation. Now let us try and understand the way how the WorstFit algorithm attempts to allocate memory to the requesting processes. So likewise here what we have is we have AN representing the allocation request, DN representing deallocation request, and we are assuming that there is a memory of size 100 kilobytes and we have an allocation and deallocation sequence that is to be followed. Now allocation is represented with the help of green and free is represented with the help of red. So initially there is an allocation request of 20 kilobytes. So we have 20 kilobytes of memory being allocated to the process. Upon allocating 20 kilobytes, we have a free space of 80 kilobytes. Then we have a allocation request of 15 kilobytes. So now we have 65 kilobytes of free address space. Then we have allocation request of 10 kilobytes. So we have free space of 55 kilobytes. Then we have allocation request of 25 kilobytes. So we have free space of 30 kilobytes. And then we have a deallocation request of 20 kilobytes. So upon deallocating 20 kilobytes, we have two holes that are of size 20 and 30, which can be utilized in order to allocate memory to the requesting process. Then we have a deallocation request of 10 kilobytes. So now we have three holes that can be utilized in order to accommodate process requesting for memory. Then we have allocation request of 15. So now whenever there is an allocation request, we will look for the block that is the largest among the free blocks and then allocate the memory to the process suitably. So here out of 20, 10 and 30, 30 is the largest block, so we'll allocate 30 to the process. So out of 30, 15 is utilized for the process. We have a fragment of 15. So we have three holes now of size 20, 10 and 15. Now there is an allocation request of 10 kilobytes. So here 10 can be accommodated in all three, but we will find the largest one that can accommodate and then allocate 10 kilobytes to the process. So the largest of the three is 20, so we'll allocate 20 bytes to the requesting process, and then we'll have a hole of 10 kilobytes created. Now we have three holes of 10, 10 and 15. Now there is a process, there is an allocation request of 5 kilobyte. So out of 10, 10 and 15, 15 is the largest one, so we will allocate 15 kilobytes of memory space to the process requesting for 5 kilobytes of address space. So now we are left with three holes of size 10, 10 and 10. So now we have allocation request of 5 kilobyte. So here what we'll try to do is we'll try to assign one amongst the three. So the initial 10 is now being allocated to the process, and out of the 10, 5 is utilized and we have a whole of 5 kilobytes. So this is the way how the worst fit algorithm works. So this is the way how the next fit, the best fit and the worst fit algorithm works. So in today's class, what we have learned about is we have learned about the next fit algorithm, right? The priorities of next fit algorithm, the way how it tries to allocate memory uniformly over the address space. Then we moved on to example of next fit memory allocation scheme. Then we learned about best fit memory allocation scheme, and we learned about the characteristics of best fit memory allocation scheme. Then we tried to understand best fit allocation with the help of an example. And then we eventually moved on to the worst fit memory allocation scheme, where we talked about the characteristics of worst fit memory allocation scheme, and then we tried to understand worst fit memory allocation scheme with the help of a suitable example. So this brings us to the end of this class. Thank you very much. Have a good day.